have to sum up once again. There are three types of series for which we have done the arithmetic mean. First one was individual series, second one was discrete series, third one was the continuous series. ठीक है, there is all there are different formulas for all the methods, whether this discrete series, continuous series, or there is individual series, right. So, on the difference in the formula is very small, but we have to remember the difference here in this case. Now parting from this, we will do some more thing. When correcting the incorrect values. Correcting the incorrect values is, it sometimes happen that due to oversight or mistake in copying, certain wrong values are taken in the calculation. For example, like in this previous case, the frequency was in this case is 10. By mistake we have taken it as 12. Or you in the individual series, suppose a student for finding the average of the average marks of the class, a student tells the teacher a wrong value, wrong marks, that he says my marks was 30, actual marks was 20. Now we have taken the wrong mean. The problem is how to find the correct mean. Now we have got the mean, but this is wrong. How to correct the mean? The process is very simple. Simply find from the incorrect summation fx, deduct the wrong values and add the corrected values, then divide by the total number observations. So result will be the corrected mean. We will do using this example. See, the mean marks of 100 students were found to be 40. The mean marks of 100 students were found to be 40. Later it was discovered that a score of 55 was misread as 85. Then find the corrected mean corresponding to the correct score. Solution: we are given n is equal to 100, x bar equal to 40. The total number of observation was 100, mean was 40. Since the formula for mean is summation x bar upon n. So we will simplify the formula. N we multiply on the left hand side, summation x is equal to n x bar. We will have the value of n, that is 100, x bar equal to 40. So we will find 4000. Now, but this is not a correct bar, because later on it was discovered the value score was 53. So corrected formula, this is the main formula. Write down the formula. Corrected summation fx will be equal to incorrect summation fx minus wrong item plus correct item. Write down the formula. Correct summation fx, summation x will be equal to corrected summation x minus wrong item plus corrected item. So incorrect formula was 4000, wrong item was minus 83 and the corrected item was 53. So simplifying we will get 3970. Corrected x bar will be corrected summation x upon n is equal to 3970 divided by 100. 3970, that is 10 and this will cancel out, 39.7. Simply the formula we have to remember, that is corrected summation x will be equal to incorrect summation x minus wrong item plus corrected item. So corrected item, misread item was 83, this is the wrong item, minus 83, 53 was the correct item, so 53. So this is the answer. There is one more example. The mean of the 100 observation is found to be 40 if at the time of the computation 2 items were wrongly taken as 30 and 27 instead of 3 and 72. Find the corrected mean. Now there are 2 items. In the previous question there is single item, Now in this question there are two items, same formula, x bar is equal to summation x divided by n, or summation x equal to n into summation x. What is n here? 100. What is x bar here? 40. Again summation x will be equal to 100, this is 4000. Now less incorrect items minus, we have to subtract the incorrect items, so both we will sum both the items, that is 30 plus 27, that is 57, minus we will get the value 3943. Then we add the corrected item, that is 75, sum we will get correct total 4018. So this is the corrected summation x. Now finding the corrected summation x bar, that is corrected mean, will be corrected summation x divided by n. Corrected mean will be equal to corrected summation x divided by n, that is 40.80. Now then with there is more one example, calculation of the arithmetic mean in case of open ended classes. Open ended classes are there when the ends are open. See, in the previous case we have done here 0 to 10, 0 to 10 was there. Now the answer was, question was given 10 to below 10, and here it may be above 50, above 50 may be above 60, 50 to 60, 50 to 70, 50 to 80, anything can be there. So this is open ended question. The open ended classes are those in which the lower limit of the first class and the upper limit of the last class are unknown. In such cases we cannot find output of the arithmetic mean unless we make an assumption about the unknown limits. The assumption would be naturally depend upon the class interval following the first class and corresponding the last class. For example, the marks was given below 10 is 4, 10 to 26, 20 30 is 10, 30 to 40 is 15, 40 50 is 8, above 50 is 7. Now in the above case, since the class interval is uniform, you see class interval was uniform, 10 to 20 is uniform, 20 to 30 uniform, 30 to 40 is 40 50, uniform is same. Length of this class is 10, this class is also 10, this is also 10, this is also 10. So since in the above case the class interval is uniform, the appropriate assumption would be that the lower limit of the first class is 0, so that the length of interval will be 10, and the upper limit of the class is 60, because we will find lower limit plus upper limit 10, that is 60, 50 to 60. So our first class would be 0 to 10, this will be 0 to 10, and final class will be 50 to 60. This is the case when we have to deal with the open ended classes in the finding the arithmetic mean. Okay. So in this case, in this open ended intervals, we will simply now we will find 0 to 10, 50 to 60. So we can perform the arithmetic mean formulas using the previous method we have done here. For in this case, this is the continuous series. You can use the direct method, you can use the shortcut method, you can use the step division method. From the above three methods, you can use anything as you feel comfortable using the calculations. Second case was when the length of the interval was not uniform. You see, here is 10 to 30, the length of interval is 20, 30 to 60, length of interval is 30, 60 to 100, that is 40. Now you see, in the above case, since the class interval is 20 in the second class, 30 in the third class, 40 in the fourth class, it is increasing by the value 10. The appropriate assumption would be the lower limit of first class would be 0 and upper class will be 150, because we will assume the previous class interval will be 10 and next will be 50, because you see there is some sequence in the length of the interval. Here is 20, 30, 40, we assume this will be 50, and similarly moving backwards 40, 30, 20, this will be 10. Agar length of interval was 10, So agar upper limit 10 the lower limit will be 0 to make the interval of length tell. So in other words, the first class would be 0 to 10 and last one will be 100 to 150. Now we have done with the simple arithmetic mean. Now we will do with the weighted arithmetic mean. What is weighted arithmetic mean? One of the limitation of arithmetic mean discussed above is that it gives equal importance to all the items. Because all the items have the equal importance, no student has given the particular weightage, but there are cases in which relative importance of the different items is not the same. When so, the weighted arithmetic mean is calculated. When the term weight stands for the relative importance of the different items, the formula for computing weighted arithmetic mean is x bar. Now in place of x bar we use xw here to simply differentiate between the weighted mean and the simple mean. So formula is summation wx divided by summation w. What is w stand here? W stand for the weight of the weights attached to the variable, that is w1, w2, w3, wn to the corresponding values of variable x1, x2, x3 up to xn. So step 1 was some multiply weight by the variable x, obtain the total value summation fx, divide the sum by the weight. In this case the weighted frequency are the, when there is frequency distribution, frequency is given for corresponding values, then the formula is w into fx upon w. Simply find fx. Fx is, that is w1 into f1x. First find fx, f2x, fnx, then multiply with corresponding weight, then sum it, divide by total sum. There is a question. A train runs 25 miles at a speed of 30 miles per hour, another 50 miles at a speed of 40 miles. Then due to repair work on the tracks, travels for 6 minutes at a speed of 10 miles per hour, finally covers the remaining distance if 40 miles at a speed of 24 miles per hour. What is the average speed of the train in the miles per hour? A train is given, so the formula, first we find the time taken in the 25 miles at a speed of 30 miles per hour will be 50 miles, 25 by 30. Time taken in covering the 50 miles at a speed of 40 miles, 50 by 40, 75 minutes. Distance covered in 6 minutes at a speed of 10 miles per hour will be 1 mile. Distance upon time. The time taken in covering 24 miles at a speed of 24 miles per hour, that is 60 minutes. Now in this case we will take the time as a weight, we will find the weighted mean. So summation 30 miles कितने टाइम के लिए दौड़ा, 50 minutes. 40 miles कितने minutes, 75 minutes. 10 miles for 6 minutes, 24 miles for 60 minutes. We will get the wx, multiply weight by the corresponding values, we will get this summation wx, and then average speed will be 6000 divided by 119, that is weight of all these three. The average speed will be 13.41. So in this lecture we have seen there are basically two types of arithmetic means are there. First one is simple arithmetic mean, other one is weighted arithmetic mean. Simple arithmetic mean, there are different formulas for individual series, discrete series and continuous series, and similarly for the weighted also there are different formula for that also. So you can do this, all the things you can do the work here. So this is the lecture for me today. Thank you very much for listening. Thank you.